This is Maui Community College, with a world of knowledge here at home.
So in this system, fluid from the chest tube enters the collection chamber. This is the collection chamber right here, just like the collection bottle. And notice the collection chamber is graduated, so we can measure the fluid volume very easily just by looking at it. Notice in these systems that once one column is full, fluid will then spill out to the next column. One of the reasons that they do this is so that we can see maybe the fluid collection starts more sanguineous or bloody, but over time, as the different columns fill, we can see changes in the appearance of the fluid rather than the new fluid just being added to the old fluid. So one of the reasons we use this spillover system is so we can identify the changes in the color of the fluid over time. And so if you look carefully, we see that 570 cc's of serous fluid is in this collection chamber. So once again, here is the chest tube draining into the collection bottle, and we can either put a one-way valve coming out of this bottle, or we can apply suction to the bottle. So here's our three-bottle system again. I explained the first bottle, fluid from the chest tube, is going to collect into bottle 1. The second bottle is what's called the water seal. And air from the chest tube goes to the water seal. All right. So bottle 1 deals with collecting fluid from the chest tube. Bottle 2 deals with identifying air coming from the chest tube. All right. So bottle 2 is the water seal, and the most important bottle of all. And the water seal is also called an air leak detector. Some of the sophisticated chest tube collection systems, they won't call it a water seal, they'll call it the air leak detector. It does a lot more than detect air leaks, but don't be surprised if you see the water seal called an air leak detector. So here's a blow-up of that bottle. The water seal of any chest tube system is going to detect air coming from the chest tube, and that's certainly something we expect. If we put the chest tube in for a pneumothorax and connect it to a water seal, then we expect it to at least bubble until the pneumothorax is resolved. But something else the water seal does, at least in very simple water seals, is to act like a check valve. It also functions as a one-way valve because air can bubble out like I showed you, but air cannot get back in to the water seal. The water seal is usually set at 2 centimeters underwater. That means the air coming in from the chest tube is submerged underwater by about an inch, 2 centimeters. And that makes it simple because all the pressure that's required to get air out of the chest tube is just 2 centimeters of water. And so a water seal of 2 centimeters, notice the air coming from the chest tube is submerged under 2 centimeters of water, and so only 2 centimeters of water is required of pressure for air to escape from the chest tube. Well, here is a clinic in Ethiopia, Africa, and this gentleman right here is obviously in pain from this procedure, and he has a chest tube, and it is connected to nothing more than a water seal. They do that because they don't expect too much fluid, and so something this simple will suffice. This is obviously a third world clinic and a third world chest tube collection system, and I assure you this works just fine. But here is the water seal of this system, much more complex. And of course the water seal of any chest tube is usually set for 2 centimeters of water. And so if you look carefully at the water seal of any system, it usually requires 2 centimeters of water for air to escape. And so the water seal of any chest tube system detects air coming from the chest tube. Well, to make things even more complicated, this system right here has what's called a graduated water seal. And that's the water seal for this system right here. We'll take a blow-up of that and draw a cartoon to show you the graduated water seal of this system. So when a small amount of air comes from the chest tube, goes under the 2 centimeters of water, it's going to bubble up into the first slot of the graduated water seal. If more air comes from the chest tube, if more air comes from the chest tube, air will trickle into the next slot. And so by using a graduated water seal, we can judge whether a little air is coming through the system or more air is coming from the system. With the old water seal systems that weren't graduated, it was hard to explain from one person to the next shift exactly how much air was coming from the chest tube only a few hours ago. With the graduated systems, we can actually consistently judge the amount of air coming from a chest tube. So here we have a lot of air coming from the chest tube, and it's making all 5 slots of the water seal bubble. Another feature of the water seal is to measure the negative pleural pressure during inspiration. When the thing is not connected to suction, a simple water seal can perform this task as someone inhales. The chest pressure is negative. That's what makes air rush into our windpipe, and the pressure is negative in the pleural space too. That means the chest tube is going to try to suck air back into the pleural space, and we can measure that with that column that's above the water seal. This one has one too, and so we'll take that and blow that up. During inspiration, the pleural space is going to try to draw in air. And so when it's not connected to suction, there will be a little float ball. When they inhale, that will come up this column. And during expiration, the pleural space is trying to push air out, and the little ball will go back down. So some of these advanced features, they'll have a little inspiration pressure column above the water seal with a little float in it, and that float will go up and down, showing inhalation and exhalation when it's not set to suction, for most systems at least. So this is another way that the water seal functions. We can see the water come up the column in a very simple system during inspiration as well. So that's an advanced feature